Hello again. Our next type of triangle congruence proof is something called the angle side angle proof. Now, this one, hopefully we're getting a hang of how these things work by now, but this one states if two angles and the included side of one triangle are congruent to the two angles and the included side of the other, then the two triangles are congruent. So, in gist, uh, if angle A is congruent with angle D, and if we have that AB is congruent with DE. And finally, we have that last pair of angles, angle B is congruent with angle E. This establishes the fact that the triangle ABC is congruent with triangle DEF. Note, this is like side angle side except flipped. You have the two angles, that the two pairs of angles are congruent, and the side between them has to be congruent as well. If it was the side on the outside, like BC and EF, that wouldn't matter. Not, at least not for now. So, let us continue with looking at a proof. So, SQ bisects our angle RQT. So, how can we approach this problem? We know, as typical, the first reason is always our given. And from here, we can establish some interesting facts, all right? So let's examine the fact that SQ bisects RQT. RQT is this angle here. And if SQ bisects that angle, it cuts it into two congruent pieces, RQS and TQS, which is our second statement. So this congruence in the second statement follows directly from the fact that SQ has bisected angle RQT. So it's the reason is the definition of angle bisectors. So notice SQ doesn't only bisect RQT, but also RST. RST being this angle right here. So it splits that one in half into equal pieces. Those pieces being RSQ and TSQ. That's how I get the third statement. So again, it's by the definition of angle bisectors. We have that QS is congruent to QS. That's kind of our reflexive property. Hopefully we're used to that by now. And then finally we can show that we have triangle QRS is congruent to triangle QTS. Well, that's because we have a pair of angles that are congruent. We have another pair of angles that are congruent. And we have a pair of sides that are congruent. And the side is between the two angles. So it goes angle, side, angle. We have angle, side, angle congruence. Now let's look at one more proof. Okay, a little bit more. So we have that JK is parallel to LM, and that JL is parallel to KM. So this is our given. And it wants us to prove triangle JKL is congruent to triangle MLK. So let's note this. We have that JK is parallel to LM, and JL is parallel to KM. Note those arrows mean parallel. So how can I establish the fact that angle JKL, that one, this angle right here, is the same as angle MLK, this angle right here? Well, let's observe the fact that, look at the parallel sides that we're working with. Both angles, whoa, it's way too much right there. We have the parallel line JK and LM. Both angles seem to touch that parallel line. And we note the transversal that intersects the two parallel lines is KL. Now, if we observe the parallel lines marked in blue, we note that the two angles are on the interior, that inside section of the parallel lines. However, in terms of the transversal, the red line, they're on alternating sides or opposite sides, right? And one of the facts we know about these parallel lines is that alternate interior angles are always congruent. So my second reason is that alternate interior angles are congruent. So always be aware of those parallel line theorems we have learned about. Now, we have angle JLK. So that's angle JLK, this one right here. That it's saying is congruent to MKL, this angle right here. Well, again, let's note that now these angles are on the parallel lines KM and JL. They are on the interior of those parallel lines. Remember, these are angles with the one tick mark. And they're on alternating sides of that transversal. So again, they're congruent by alternate interior angles. Are congruent. Now, finally, we have KL is congruent to LK. Well, that's just because they're the same line, meaning that's our reflexive property. So what we have now is that we have two pairs of congruent angles. Here's the first pair, here's the second pair, and a pair of congruent sides. The side is between the two angles, hence we have angle, side, angle, congruence. And that completes our proof.